thanks very much to the organizers for giving me this opportunity to speak here. So this is about waterproof, and indeed, our project has a lot of the same goals and also solutions as verbose lean, which Patrick just introduced. I will try to minimize the overlap, but will also be not able to avoid it because some of the things that he put very eloquently are just right there in my slides, so that, okay, you will see it back. I would like to stress in the beginning that this is a project with input and help from many, many different people. And I've put a few on the slides, but on this slide, but definitely not enough. I would like to highlight a few, though. Jelle Wemmenhoven was a PhD student working on waterproof. Currently, Pim Otte is a PhD student working partly on this topic. Pim is also supervised by Johan Kommelin and Paige North, who are in Utrecht. And myself, I'm in Eindhoven. The next name on the list, I'm very grateful to Paul-André, actually, because he was an internship student who went to Eindhoven to work on waterproof, and he brought the software from version 1 to version 2, which doesn't say anything except that we found it a very important change. I would like to highlight also Rianne and Dorina, who are from human technology interaction, human-computer interaction. So we do this work with input from people with expertise in those fields, and also with people with expertise in educational science, Alexander Schuler-Meyer and Nick Hoofd. And then there are many, many, many bachelor students who contribute to this, because we have this software engineering project that was running at the end of the bachelor, where a team of 10 students would work on a software project for a client. I was a client several times. That's really many hours of input. So I'm grateful to many people, including other people that are not here, but are more in a supporting role, like Emilio. All right. That being said, I'm going into this. So there's a bit of a delay. Okay. That's okay. So I also wanted to say that where I come from in trying to develop waterproof, and what was part of my main motivation is, indeed, I was teaching Analysis 1. I was an instructor at that time. And indeed, students, when confronted with exercises, they just didn't start the exercise, staring at a blank piece of paper, while you feel you could do something. You could at least introduce your epsilon. And that didn't happen. And then they hand in homework, and I give feedback on the homework, but it takes some time. Also because I couldn't understand the proofs, and I don't know, but my brain very often short circuits when I read some of the proofs. By the way, I really like my students. I really like teaching. It's not to diminish them. But I was giving feedback, and at some point this is a measure theory, and you have not defined I0 here, and this is it keeps happening. So. And then the quantifiers are missing in the wrong order, etc. I think the problem is recognizable. And I didn't like the feedback loop that it took a week. Can we change something? At the same time, I was responsible for the practical component of a very large course in Eindhoven. Every student, every first-year student in Eindhoven had to take this course, which was more than 2,000 students. And they were learning about data analysis, but part of that was learning how to program. And that actually went quite well using the Jupyter notebooks. Students had this freedom to explore here. They got immediate feedback, and we could teach, or students could learn regardless. They could do architecture, psychology, and technology. They didn't like programming, but they were able to pick it up, right? And I was wondering, how can we be kind of successful in teaching programming while we cannot teach proofs or to our own mathematics students? And then I thought, can we teach proving more like we teach programming? That was the idea. Okay, and then we have our tools, proof assistants. They give immediate feedback. There are consistent rules that you can follow, and you can experience them when you interact with a proof assistant. You can make mistakes without any consequences. So you made a mistake, you change it, it's okay. It's not that it's immediately graded. And a very important point for me was also that you get to 100% correct. So I don't know exactly for a mathematics proof to say this is 40% correct. But this was my feeling when I got a lot of these exercises. And at that stage, you cannot communicate any subtle points where you feel that's where you actually need to do the teaching. But the proof assistant helps students to get there. And then many people have taught with proof assistants. This is a way too short list, and I focused on people using proof assistant for teaching mathematics in this list. It definitely goes back to the 70s. Yeah, and if you do this and you feel like you should have been on the list, please let me know, and I will try to add you next time. There is a very nice survey by Frédéric and by Julien. Then you can also look into whether this actually works, and people do that. And especially the first on the list indicates that problem that also Patrick was saying, that the problem with the transfer. So you can become very good at writing proofs in the proof assistant. Doesn't tell you anything about whether you can then actually write proofs down on paper. Other things that come up is it just has a very steep learning curve. I think a lot of us experience that. But there's also kind of points that may not be so related at first. For instance, difficult installation. A couple of years ago, like, you were advantaged if you were on a Linux system, but a lot of students were on Windows, and okay, maybe you could install CockID, RockID at the time, but then you didn't have the libraries that you wanted. You wouldn't. So it was kind of difficult, and this matters. This is the first interaction with the software that students have. And if that's not positive, it's going to reflect on the rest of the course. Appearance matters. So we all have our preferences for IDEs. The VS Code editor does have its perks in terms of looks and design, at least to some people. The feedback is nice. You have immediate feedback, but very often it's local. It's very restrictive. It's like only pertaining to certain parts of what you're doing. And very often you cannot quite decipher it, at least as a student. And this I mentioned. You can be able to write proofs in a proof assistant, and then still, this point was made. So this is why we started working on waterproof. And maybe as explanation of what it actually is, it has two parts. It has a front end, which is the editor. This is where students interact with it. And then there's a back end, which is basically a library or technically a plugin for Rocq. And it is related to many other products. And I definitely didn't put enough names here. Verbose Lean is the closest in terms of the library. But even Verbose Lean, because Lean has this widget mechanism that allows for interactivity, some of what we have in the front end is provided on the library side in Verbose Lean. So, yeah. Let's see what it looks like. This is what it looks like. Quite similar in terms of text. So we see here an exercise. It's a trivial exercise. 2 is the infimum of 2, interval from 2 to 5. And in terms of language, the language is a bit different from Verbose Lean, but similar. And this is the easy part of proving an infimum, right? This is the trivial. Okay. What do I want to highlight here? I think because you have seen Verbose Lean, it says, okay, it looks quite similar, but we have this embedded in VS Code, and there is this red bar on the left-hand side. So students can write here, the cursor is actually blinking there, and then they can write the final line to their proof, and the bar turns green, and they're finished. So there is a little bit of this feedback. Also very important is students cannot really write outside of the input areas. So in this big course with 2,000 students, a large part of my job was when they handed in their homework, it didn't work, and then accidentally they had changed something outside of the input areas. It was very difficult to debug. So we didn't want that. Everything outside of input areas should not be able to edit. Okay. Now, because we want the transfer to paper, we want students to be able to give proofs on paper in this course. Writing a proof in waterproof should be as similar to writing a proof on paper as possible. It's not completely true, but this is what we have in mind, both in terms of the proof script. so the final product, as the process. And this is some illustration of that, but not so important. What I would like to tell you about today is, I'll tell you a little bit about the educational context so you have a bit of a better picture where we are using this and what kind of course we're using this. And I'll tell you about 2 evaluations, but very briefly, because in the context of Malinka, I think it's nice to know how do students interact with this. And also afterwards, like where do we see this going? And in that part of the talk, I will bring in the LLMs and see what they could do for us, if we want that, and just maybe think out loud together with you, like where the future lies for this. So I teach, so we started this in 2019. Back then, use of waterproof was not compulsory. Of course, we started piloting it, but recently, last year, it was compulsory for all students. And all students was 270 students. So it's a really large course. And of course, in such a course, you have all different levels of students. Students that are picking this up very quickly, but also students who have a lot of difficulty proving mathematical statements. What a course looks like, I teach twice 2 hours per week. So in total, 4 hours per week is just ordinary lecture. And then we have tutorial sessions where students work on homework. We do some exercises together with them, some explanation maybe on the blackboard, and they work on waterproof. And in terms of deliverables, they need to hand in homework still. That won't be sustainable for very long. They need to hand in waterproof, and they have a final exam, a midterm exam. Any questions about the setup? Or is it? Okay. Yeah, maybe one thing before I go on. Another aspect of why I like working on this topic for students is that students are a bit of a tough crowd, right? So they don't have too much patience with syntax or with tactics or anything. So we constantly need to think, how do we make this as easy as possible for students and still keep it didactically responsible, right? So that's a fine balance, but we do need to think, okay, can we do this easier? Is this error message, is this good enough, and things like that. And even though I agree with Patrick that this is not how we will be writing our formalized project as mathematicians, I do think that sometimes while working on such projects, you get input on, okay, where can things be easier when you start formalizing things? So I do hope that by working on projects like this, we get some information as well how to make proving in a proof assistant easier in general. And I do think that there's still a need for that as well. So I just wanted to say that. Okay, 2 evaluation. One is from human technology interaction. These were some methods that we used. We used a co-design session. We had surveys. We interviewed students. And we did log data analysis. So this was with consent of students, and they uploaded the logs of their interaction with the system. And then we could analyze that with some process mining, it was called. And we could kind of, yeah, you cannot decipher this, I think, but we tried to see what they were busy with, and when they were stuck on an error, for instance, that was one of the categories, how did they resolve that error? And we saw that they would open a tutorial, or they would look at a side panel where they could find all kinds of different sentences that they could write. But very importantly, they also waited until the next tutorial session and asked an instructor. So we also logged when the tutorial sessions would start, and they sometimes you saw, okay, they were stuck on something in their proof until that tutorial session started, and then it got resolved. So what we learned from this is several things, but one, errors played an enormously large role in working with proof assistants. Almost as a caricature, students were just stuck on an error the whole time, right? Error, and you fix it, and then you're stuck on the error again. And that's one thing. The other thing is that the role of people involved is very important. So it's tempting sometimes to see as this library or the IDE or the combination of the product as the one thing that you're developing, but it's very, for us, and maybe to some of you this will be obvious, but it's important to see this in the context of a course. How do you integrate it in the course? How do other people relate to it? What are their needs? And so we have the student, but then there's also teachers involved. There are developers involved. And maybe, of course, you could say the needs of the developers is not so important, but okay. Needs of teachers, it was a course with almost 300 students. I don't do this by myself. I have 6, 7 colleagues. And like many mathematicians, we have very clear ideas on how we want to teach mathematics, and they don't always agree with each other. Actually, in all the contexts that I've seen, people have diverging opinions on how to teach. And that's perfectly fine. But if you introduce a tool like this, it kind of limits the way you're teaching. So you kind of have to see how you can get people on board. This was important for us. So we really want to see this as not a standalone product, but integrated service provided together with teachers. And also the help that teachers can provide to students is very important. Now, this predates things like Copilot, but we have to see how this is going to fit into this picture. We provide Waterproof as a VS Code extension. I'm sure that people will have either ChatGPT open, okay, that's with 100% probability, and then there is whether they have the Copilot agent open, that's maybe at now 20 to 30% probabilities. My estimate is not measured. And this is going to change as well. So do we want to integrate this somehow, or do we want to keep it external? I won't say much about this, but we also try to see the effect of what we're doing. So our proofs written by students who write in Waterproof, or maybe other proof assistants, but in our research we worked on Waterproof. Do students really write better proofs? Do they write different proofs? Do you see something in the structure? And the short answer is yes. So we did some proof analysis and between students who did use Waterproof, who didn't use Waterproof, and we did see some differences there, both in the positive side. So students using Waterproof did structure their proof better, they signposted better, so they told us, the reader, better what they were going to do. And there was one place where they performed worse, and I will come back to that, because we can kind of see that we didn't train them well enough, or the activities that they had to do in the proof assistant didn't align with what we wanted to have, wanted them to do on paper. So we will see that. I want to skip this slide. Okay. Now let's talk about the interaction. And we start with onboarding. I already talked about installation, that we really want this to be very easy. And luckily, things are improving. So I really like that in the past years, for a lot of the issues that I've also mentioned, improvements have come in the community. And one of them is the Rocq platform. So this is, it has maybe multiple purposes, but one way you can use it as a teacher is you can make a customizable installer. It's almost a one-click installer. I think officially it's like 5 clicks or something like that. You can preload the environment. So we put our Waterproof library in that environment. Maybe MathComp is also shipped, something like that. And then you can run the script, and you get an installer. Users only have to click 5 times, and they're up and running with the tool. That was really, really useful for us. But then 5 clicks, still a lot, and it didn't quite work for people using Linux, and didn't quite work for people using Mac. I know that there is support in Rocq platform for Mac, but we had problems signing the installer. Right? So technical things that you run into. But then, with many help from Emilio, but also Shahar, I believe, we now have a version that runs completely in the browser. So there's no server side to this. Before that, we had a server. We used Gitpod, but that's not really viable anymore. And Codespaces, that's also a nice solution. But even nicer if you're not relying on some service. And now, indeed, it's just Rocq running in your browser. And we couldn't have done that without Emilio. And yeah. So thanks a lot. And so what you can do now, and later there will be a link to Waterproof. You can go there, hit period. So you come at some GitHub with our exercises. You hit period there on GitHub. You go to GitHub Dev, and you can start working on the exercises. So no install necessary. Okay, that was installation. Hopefully that went well, and we recently tried the web version in Utrecht, and indeed students were up and running within 2 minutes. So that was good. Now, how are we going to get them to write in this proof assistant? Well, we decided, or we tried to have basically around 15 standard moves that students could use, maybe 15 tactics, let's say, and we present them in a tutorial. So I don't know what should be the optimal number, but it's a balance between, it needs to be expressive enough that students can do the proofs that you want, but it shouldn't be too large because then you cannot communicate it. So here also the goal of the course is to write analysis proofs on paper. Basically, we have no time to teach how to use a proof assistant. So this onboarding, this learning how to use the tools should be quick, and students work on the tutorial where we have the kind of 15 tactics listed. They work on this for 2 hours, and then they can somehow sort of do this. But how can you know what to write besides reading it in the tutorial? We have 2 other methods. We use snippets and autocomplete. So if you hit Control Space, then you have a list of options appearing, and you can scroll through it and then choose the one that you would like to have. Alternatively, if you prefer that, you can go to a panel that lists a bunch of tactics, and you can press maybe the pencil, and the tactic will also get inserted in your proof script. So here you again see maybe the 16 moves that you could make in slightly different variations. Okay. Now, there are 2 messages in this slide. First, how can you then interact with it? Well, this is a snippet mechanism in the editor where you hit tab, and then automatically your cursor goes to a place where you can modify something. So here we can modify X to M, and then the 0 to 6. Okay, that's a nice gadget. But it's important, just like what Patrick was saying, if you mistype choose, then you get error messages that you don't quite understand. So we really want students to be able to write exactly in the syntax that we need. And then the snippets become very important. And there's a second related to that message here. And that's before we just put in some comments. So like choose, and then, okay, here you should insert your variable, and then is equal to, and here you should insert your value. And that created a syntax error. So the parser did not know what to do with that. And that creates problems. So this is also a small feature, but it is a very important one to reduce these syntax errors that students don't know anything about how to fix them. So we just say choose x equal to 0. Now x is not the variable that they need to introduce, although you could maybe debate about whether you would like to allow renaming or not. And 0 is not the value that it should have. But as soon as it's syntactically valid, then we can give much better error messages, and students can fix it themselves. So, and we have this help functionality that you also saw in what Patrick was saying. And yeah, we really like Patrick's click interface, and that's also maybe more general in Lean, so we try to start incorporating it as well. So you can now also just click replace, and the help gets replaced by what you can do. Another detail here is that we would be able to just insert take X in R at that stage. We decide not to because we feel the student needs to write something to actually pick up on what they need to do. So if it would just be fully, we could maybe generate the whole proof, but that wouldn't really help them, right? Okay. We do have markdown rendering. This is maybe trivial, at least on the user side, but we feel this is very important with the looks. And a lot of our students, they don't like programming very much. And then to have a software where it doesn't look so much like programming can be an advantage. But it also clarifies the meaning of the text that we want to write in our document, or the messages that we want to give them. Okay, it seems that I have... Oh, Something is happening. This was getting help. This is markdown. And here we expand a definition. It's our design that the proof script reads like something that you could write in a notebook or on an exam. And a tactic like unfold square would not really fit in our opinion of that. So we do give the possibility in the language to unfold square, and here the way you do it is you say expand the definition of square, but then we don't want to have that inside, and the mechanism is that some options appear for the students for replacements. This is very similar to what Patrick, I think, does in the help tactic. So we got inspiration from there, but then it gets replaced by a reformulation, in this case, of the goal. We have some function notation that aligns more with mathematical notations with brackets and commas, and it seems insignificant, but especially for convincing colleagues to use it, it's not so insignificant. Yeah. I would like to go through this running example with you to illustrate a few things. It's a very silly proof, and we don't use this in practice. This is just a cooked up example. You could look at this and say, and I'm sure if you say take this, that's just the intro tactic, so you could write this. I want to illustrate it's a bit more. We do more than that. Because if you would, if take would just be a wrapper around the intro tactic, then writing take M would do the same as intro M at a place where you need to show an existence statement. The feedback that you get from Rocq is no product even after head reduction. Yeah, I cannot explain that. If we instead use our tactic, then it says take can only be used to prove a for all statement or to construct a map. So controlling the error messages is a very important part of what we do. Here's an example where we make a spelling mistake, choose with a Z here, which is not the right spelling. And then the error is syntax error, LTEC use default expected after LTEC2 expression in LTEC2 command. Yeah, it's not very useful. We're working, and we have help from Emilio and also from Gaetan Gilbert to have the Rocq parser give a little bit better error messages. But for now, what we're doing, we're just filter them. So if it's syntax error, then we say syntax error, remove everything that I also don't understand, and then say something about how they might be able to fix the error. Now I come to this place where we saw that waterproof users performed worse than the non-waterproof users. And I'm going to try to explain this with this example. So we used to have this syntax for, the same exercise. It's the same exercise, but with old syntax, because we didn't know how to do the notation with there exists an X, or there exists an M between 30 and 35, in the interval from 30 and 35. We did not know how to do that in Rocq. And we thought, who cares? We just write it in the equivalent form. And as Patrick was also saying, students don't mind. I mean, my experience is also, it's a first-year course. You can tell them anything, yeah? They accept it. But it did have an effect that we did not quite foresee, but it was a bit annoying in the sense that how do you now deal with that quantifier there exists M of type R? Well, you provide a choice for M. And then you move on with your life, with your proof. Now, if that's the reflex that you have when dealing with the existential quantifier, then you're never going to check that in such a case that your M that you choose is actually in the interval. You deal with a quantifier, you provide something, and then you move on with your life, but you then, as you move on, you forgot something. Right? And that's what we saw back in our measurements, that students just did not check that M wasn't 30 to 35. And then we worked very, very hard to get this notation working in Rocq. It was there in Lean already, but we tried to do something to make it also work in Rocq. And now this is what we do. The funny thing is also that now if you look at students' work, very often you see the curly braces and then indeed. And I also forget this a lot when I write on the blackboard, but now I have students in the room that say, hey, wait, you need to check that your provided n is a natural number. That's an amazing side product of working with this. Yeah. Then in that same example, we constrain students what they need to do. It's not so for instance, here, after introducing indeed, they cannot move on until they either conclude what they needed to show, or they remind us, they signpost what we need to show. And in this case, it's maybe a little bit silly because we remind it, but it's just one line in between to verify that m is between 30 and 35. But this check could, in principle, be quite long, and then the proof would continue. So we would like students to write at that stage, oh, I actually now need to show that for every x between 0 and 5, x squared is less than or equal to m. And we enforce this by actually doing something on the Galena side, on the Rocq side. So they cannot do anything with that term anymore. We wrapped it until they actually write this line. And the use of this is maybe a bit better illustrated here, where you do a case distinction, for instance, whether x is less than y or x is larger than or equal to y. And then normally, if you use the ordinary Rocq tactics, okay, you know by the order, but in principle, you don't know in what case you are. And here, you could, of course, comment it, but yeah, nobody's going to do that. So we enforce it. You cannot move on until you write that you're in case x less than y. We have a lot of automation as well in the background. We make sure that some statements, we care about this. We also want that students write, let x be in 0, 5. In France and in Netherlands, we have similar learning objectives in that respect. So this should not be able to prove automatically. We shield that. And there's a way to tune the database. This is too much detail, but there are ways to also say, okay, these lemmas we accept in the course as just free for use, and others we don't tell anybody about. I'll go through these two slides quickly, but so here, if you provide a different condition, so here you need to show that for every x in the interval from 0 to 5, something happens. If you then write take x in 0, 4, then you get an error message. This error message is actually not so good. I think this needs to be improved, but you get the idea. Also, Rocq doesn't really mind if you rename your variable, but we would like to keep our proof scripts relatively clean, so we give a warning. If a user, a student, decides to rename the variable from x to y, then we say, oh, we expect actually a different variable name. And then you could, this would also be a perfect way of the intro tactic, and we say this doesn't work. Okay, this is a bit of a joke, but. Okay. And then what helps sometimes in devising your proof is just postponing something. You need to choose an m, you need to choose a delta or something, and at the moment that you need to do that, you don't quite know how to do that. So we can leave it open. You see, choose m is equal to a blank. And then sometimes you don't know how to prove something, and then you can write by magic something, something. This is equivalent to sorry in lean or admit in Rocq, but we have slightly different syntax, and we can remove by magic once you know how to prove this. So it helps. Like, you would like students to start working on their proof, to continue on their proof, and then just postponing something, it helps to build the proof structure or the proof framework, and then it can come back later. Of course, this does have the side effect that on exams you will find from time to time, by magic, this and this happens. It's a question, okay.
So maybe a quick question on this is that when you're doing these sort of things in like vanilla Rocq, you can kind of accumulate some conditions on M by like looking at what you admitted, and then you can kind of use that information to inform what you're doing, what you should use up there.
Yeah.
Do you have access to this sort of information as a student? If you do this script, do you at the end see that M should be a value in 35 that verifies this condition to kind of help you choose the value?
So not really. And part of the reason is that we hide the info view. Because, again, if you do some proof on paper, you don't see the info view. Now, this is, not everybody has the same opinion, and by now it's customizable. So if you would like to see the info view in waterproof, you can, but by default, we hide it. And so therefore, you don't have that information available. So you really need to get it out of the proof script. I went through a few things. So we have a very cheap version of lean calc blocks. They are not comparable at all, but you can write these chains of inequalities in the library. And then for some things, you sometimes get surprised. For instance, I was always a bit underwhelmed by the specialized tactic. I never really saw the point. And we postponed implementing this for waterproof. Like, why would you need a specialized tactic if you can just write it holds that? And especially if you use a hypothesis that is true and it holds for all epsilon larger than 0, that's something something, then you just write it holds that something something where you substituted the correct value for epsilon. And I thought that would be great. This just didn't communicate with students. I could say this, they wouldn't get it. And then we started introducing this specialized tactic where you say, okay, use now M1 is 7 in this formula. And this changed things a lot. We could communicate about this proof step, and students picked it up. It was, yeah, we were very happy with this, but we had postponed it for about 2-3 years to do anything with it. Right, this is just another thing that we run into teaching the proof assistant. Is this true or false? And in our software, this is false. And it is because, okay, all these functions are total functions, so if you do 0 minus 4, that's going to be 0. But how I still cannot explain this to a student. Technically, yes, but they would look at me and say, okay, this is... But Yves Berthaud has a good suggestion for this, where you just embed the natural numbers in a good way in the real numbers. I know several, so also I think Julien is now using this approach as well. And we are using this in newer versions. So I think it was a great idea. Now we come to the, so how many minutes do I have left?
Like 15, maybe, let's say.
15?
Yeah.
About 15. Okay. So come to the question, can LLMs generate waterproof proofs? And this was some sort of culture generation clash between a bachelor student that I had and me. We had very interesting discussions, especially in the first 3-4 weeks of his bachelor project. This was Mikołaj Pujanek. Okay. And I said, LLMs cannot do this because there is almost zero, practically zero training data online on how to write waterproof proofs. There is like one repository, and that's it. So that was my argument. Mikołaj's argument was, they can do it because I've never seen LLMs not being able to do something. So that was... Now you can guess who was wrong, but I'm telling this to you, so it's probably going to be interesting, and that means that I was wrong, right? What did Mikołaj do? He took the tutorial. It's very similar to what Adrian actually was saying. So he took the tutorial and uploaded it as the context, and then said, okay, maybe also keep in mind this common error and things like that. And then they started being able to write these waterproof proofs without knowledge. If you don't do this, it's gibberish, what they say. They don't know the syntax. But if you write the tutorial, add the tutorial, they start writing correct proofs. This is not really a good metric. So it's not pass at K, so we put success at K. But maybe just... we have a loop as well, as we've seen earlier in the conference, also with Guillaume and Emilio's talk. We let an LLM generate a proof. This is a general purpose LLM. And then it makes some mistakes. And we give the error message from Rocq back to the LLM, and it can iterate. And then over the number of attempts, it starts to get better. And this is average over all exercises that we have. And Best models, they come to about 60%. And where it really seems to be limiting is that when you unfold definitions. So of course, the LLMs have some knowledge of what it means for a set to be open, but it might be formulated slightly differently from how we implemented it in our library, and then they make mistakes. It's difficult to recover from it. And of course, the solution would be to give the LLM the tool to unfold the definition. We're just not there yet. But that seems to be the dominating factor on why these models are not more successful. Yeah, this is just a visual overview. On the x-axis, we have all different exercises, and on the y-axis, we have different models, and yellow means that they are able to solve these exercises. And this is an excerpt for a very simple exercise. What happens in attempt 1, there is a little bit of mistake actually in the syntax. We need to show that is... by definition, we need to show that that's not valid syntax, but it fixes it in attempt 2, and it writes by definition, it holds that something else. And then there's still a mistake in the second line, and because we have this, we need to, if we say we conclude that, it should really correspond to the current goal. It learns that, and it's done. So it's a very simple proof, so this is not so impressive, but this is just, we have the attempt on one slide. Some observations that we have here. It was crucial to upload a tutorial, otherwise this doesn't work. But when we do upload a tutorial, it works actually quite well. Now, sometimes models start to so this is really, there was a lot of fun because some of these models have the thinking, they have thinking enabled, and then you can read what they are thinking. And at some point, it's really strange because they explain to you that they discovered a mistake, they shouldn't use a certain form of bullet points, and they fix it, and then they fix that after that something else, but the bullet points are wrong again. And this was very, it's a fun read. But this improves, so it improves that, what is the problem? So they fix a mistake, but then reintroduce mistakes at other places. This improves if you first ask to strategize in natural language. And maybe another thing that we notice is sometimes errors that the models make, it's not their fault actually. So we should have done something better in the library. And this brings me to also a bit of a sad point, which is we anthropomorphize a lot or let's say I anthropomorphize a lot the LLMs that I work with. And then I start to see them as sort of students, and they are quite similar to students in some respects. So if we don't give good error messages, then the right information doesn't come across. So sometimes they kept doing things wrong, and then I looked at the error message and said, okay, this is a terrible error message. How can you even get any information out of it? But what made me sometimes really sad is you can fix some of these things by just adding another instruction, or maybe another instruction to the tutorial. And then they fix their errors. And what makes me so sad about it is that they actually read what you tell them, right? And somehow sometimes that's a difference with the students. Yeah. Now, that made me truly a little bit sad. So there's also, the LLMs don't always follow instructions, they follow them sometimes. Okay. We started to implement this in follow-up student projects. This is the YouTube demo. And now they use LLMs to fix syntax errors. This is a different approach. I don't know if this actually does. Yeah, okay. So they can hover over some errors and they get some feedback. Okay, that doesn't look good. Another team improved this help mechanism or the hinting mechanism. There's no demo of this, but this is what it looks like. You can ask for a hint or provide the next step. And now Dick Arends, who is doing an internship with us, he's prototyping this in some sort of agent. And we definitely don't know if we want to go this direction or not, but we do think it's important to explore what this brings us. So I'm waiting for this to start. It's not doing anything, right? Okay. Somehow the computer seems to be freezing every once in a while. Okay, but here we can ask the AI assistant, we call it for now River, we can ask it for a hint and it will give you the next step in kind of, yeah, if an instructor would have given that hint, I would be completely support it. So it's even encouraging, but we know that about LLMs that they can be quite encouraging. It's very encouraging to the student to move on and it gives a correct next step. So that's great, and then when I read that, I think, oh, we really need to do something with this because they are struggling on things they shouldn't be struggling on, and this will get them unstuck. And then you ask the follow-up question, okay, so what do I do now? And then it's complete nonsense again, so then I think, oh, maybe we shouldn't do this because we need to control what we tell our students. It shouldn't be, yeah, we have a responsibility to tell them true things, and we don't have control when we use LLMs at all. So my computer crashed, it seems. What? Oh, it's back. Ah, here it is. So it's important to validate the hint that you're getting, but it's not really. So we ask for the correctness of the hint, and then say, oh, great progress so far. You see, it's encouraging. Let's try to apply hypothesis 1. You try it, and the suggestion actually works. So after this, I'm thinking, oh, this is great. And then I ask the next question, and I think, oh, no, we should stay away from this. This is where you can find the software if you want. I'll leave this up for now. I'm going to close. So we use this to help students writing their proofs. And I think that there's a lot of research necessary, and I know some of you are doing that research to see whether that is helpful and how we can make it better. So let's keep doing that. I think it's especially important to see how we can integrate these tools in courses better. But I would like to finish on this note that in mathematics, a lot of, at least it's my personal statement, right? But I feel there's a lot of cultural value in mathematics being hard and us or people being smart. So that plays a big role. But especially if we're teaching, I feel sometimes my duty is to help students realize it's not that hard. So starting a proof is not that hard. You can do it. Maybe there's one step in a proof that it needs analysis proofs, right? That's maybe a bit complicated, but the majority of things are very accessible to you. So part of the reason I'm working on this is I want to make mathematics easier for students, and especially on the student level, I think this is very achievable. So my motivation for working on these topics, and I hope maybe that Malinka will also help in that direction, is that we make tools that make mathematics easier for people in general. Okay, on that note, I would like to close.
So thank you, Jim, for your great talk. One question here.
Thank you for the talk. So, a small question. What areas of mathematics did you also try to represent in What's a Proof except for real analysis?
So we do also have Intro to Proofs, and that runs now, so that works relatively well. And we tried with linear algebra. Linear algebra is a little bit difficult, and I think this came, Carlos said that before, like the ellipses is incredibly difficult to deal with, and we also noticed that. So in let V1, V2 ellipses, Vn be a basis, and I still don't know how to represent that well. So yeah, the linear algebra didn't work yet, but algebra itself was again went pretty well. So simple algebra things was good.
Hi. Yes, thank you for your talk. I actually had 2 questions. The first one is if you could clarify a bit how are you generating the different attempts? For example, if you're putting in the context the stack trace, the error that the ID generated or whatever. And the second one was about strategizing the proof, because it looks like this chain of thought, well, as expected, is helping solving the task. But I was wondering, like, what kind of chain of thought strategies did you try for this? Thank you.
So we didn't do many fancy things. So in terms of chain of thought, strategizing is probably something like, please first think of a nice natural language proof for this statement. So if you have anything better. And also the updates we I think ran locally with the Rocq compiler and extracted the errors and maybe I'm not even sure if the student got to really extracting the goal state or only giving back the errors. Now with Dick's work, we do more. And actually we rely on Pétanque at the moment to like execute certain statements in the file and see what their effect would be. And we have nice access to the goal state. And that goes back to the agent. And yeah. It's work in progress, so that we add more, but this is the way we're thinking about it currently.
Thank you for your talk. I have a question. Do you use with your students the pattern search for theorems or lemmas? Because when I was a student, I remember the thing is you gotta read and learn your classes, your textbook, and you gotta sometimes you have a proof and it relies on a fact and you have to see it. Yes, there is this fact, I can use it. And sometimes the students just don't learn or don't see the thing, but I think with Rocq and I'm a user of MathComp, so I find it interesting in that you can search for a lemma with a pattern, like, oh, I need something that looks like this, and see what I have. Do you find that your students, or do you use this search, and do you find that there may be better because of this?
So it's a very good question. It has a multifaceted answer as well. One is we don't use it, and the reason is similar. We don't want, to what Patrick was saying, we don't want students to remember these lemma names. So this way of proving that you sometimes end up in when you're using with a proof assistant, like invoking this lemma, invoking that lemma. That's not the model that we advertise to students. We think this is not the way to go there. And I think it was also Heather Macbeth who said, instead of applying these lemmas, you would like to work with certain tactics. So maybe a little bit broader tactics that have a very specific function that correspond to a clear mathematical argument. And rather than invoking the lemmas, you would like students to learn how to invoke the tactics. So that's the approach that we take, and that puts the search functionality a bit on a sidetrack. I mean, if I work on formalization, I use it also quite a bit. I find it very useful, but it's not so useful for the course. And I also feel that, I would have to think about it, how to embed it in the course if I were to use it. But there's the other aspect to what you're saying as well, is that if you use it with a proof assistant, then you ask, oh, please unfold the definition of continuity. It's there, right there. And that doesn't help students remembering the definition of continuity or remembering what lemmas they need to use. So because, we need to remind them maybe of an existence of a tactic, and we say, oh, in this exercise, you can probably use this tactic. While as a learning objective, you might want to have that when they see an exercise, they think of the procedure themselves. So this is, the proof assistant is not a replacement for everything that is happening in a course, but this remembering a definition and maybe seeing what lemmas to apply is not something that is a skill that is learned by use of waterproof at this moment. Yeah.
So I was wondering, I mean, there's a lot of things that you do on top of Rocq that maybe would actually be better to have in Rocq. Like I was thinking about error messages, always one answer that, like, I mean, a lot of your error messages are like miles better than the ones we have in native Rocq. So I was wondering, beyond this like very obvious case, are there things that you've done in waterproof that you think should be backported somehow, or like could be backported to Rocq if like the capabilities were around? Like what would you push down to Rocq rather than keeping them at the waterproof level, if you could?
There are several things, so it would be I would like to sit down and make a list in a way, but the calc blocks or the chain of inequalities that we have, then generalize them to the level of calc blocks in Lean. I think that would be really nice. Yeah, I think I need to think a bit more about.
I think that's really probably an interesting list to have around for like the Rocq people.
Yeah.
Like all of the cool things that you know how to do in waterproof that maybe we
Ah,
don't have at
yeah. One.
That's really an interesting data or like document to have.
Yeah. So another thing is around notations, and I mean. Of course, in MathCom, there's also incredibly nice tricks with notations, but for us, it's very often, it feels like hacking around. And also, with every upgrade of Rocq, it turns out that we did things that we were, in a way, not allowed to do. It's like you get new warnings, like this is going to be deprecated. You do this, but not. They shouldn't do it in 2 versions from now. So a little bit more robust system there could be nice. But yeah.
Thank you.
Okay, so we still have a few questions. So, Michael? Yeah.
We're keeping Paul-André fit. So I would like to ask the kind of dual question to my predecessor. So if we look at what you're doing in waterproof, you're building a whole lot of stuff for the educational application on top of the kind of Rocq as an engine of truth.
Yeah.
Right? And you have to kind of restrict what goes into that engine and so on. So could you comment on kind of what's the more important part? And I know you're going to kill me, but could you just re-implement the portion of Rocq you need easier and kind of make yourself independent? Is that a viable thing? That's what we've done in another project, and it turned out to be great, right? We're only using 5% of Rocq. Let's just do something viable by re-implementing that and keeping it lean and, mean and lean, but not lean.
Also here, there are different components. So at the same time, I think we can reuse better what other people are doing. So that's already. There's a lot of good stuff in Rocq that we rely on, and us re-implementing it would be some sort of, maybe not be the best use of our time, but in other aspects, it is true that we use Rocq as this basis of truth, but we could get it from other sources as well, and we could also start to reflect on how much it really matters in an educational context. I mean, an approach might also be a good basis to work on, and part of it is definitely also to blame for ignorance on my side. But then the landscape is so large that it's kind of difficult to see what a kind of tool brings, and difficult for me, what a tool would bring to me without actually trying it out, and before you know it, you're kind of invested. So I think you're right. It would probably pay off to sit down and think, what do we need, and what would be the best way to achieve that. And with the caveat that it's good to see if we can reuse work from other people. Yeah.
Okay, so we have time for last question.
Thanks for the talk. Maybe it's a trivial question. I am not really a user of proof assistance, so but it made me think from a pedagogical point of view. What does it mean to have a proof that is not 100% correct? And if I think to my students, normally what I mean by that is a proof that you can accept as correct, but there's some phrasing, there's something that made me think that they are not grasping the right concept behind, no?
Yeah.
And yeah, I see that something like this will provide you a proof that it either 100% correct or not.
Yeah.
And my question is this resolving the problem by teaching to the student how it works and how to grasp concept, or hiding a little bit the thing? And how are there tools that can still help us measure this ambiguity? I don't know if...
Yeah, so what is the ambiguity that you refer to? It's like...
Well, the fact that one can say something that is formally acceptable, I mean, semi-formally acceptable and correct, but still giving the impression of not grasping the right concept behind.
Yeah, so, okay, that's hiding that. That is true. I'm not sure how that could be done. I think how we currently do it, but it's not the best answer, is just walking around and see how students are interacting with the tool and whether we feel that reflects a bit their understanding, yes or no. And sometimes for some students you see, okay, this is reflecting understanding their actions that they are taking, and for sometimes with some exercises you feel, oh, they maybe are just trying things out, or they wrote something down and suddenly it works, but they have no clue. So we walk around, we try to design our exercises in such a way that it works, but besides that, I think currently we also need to rely on the just handwritten proofs to cover that.
Maybe the same rewriting the proof and
Yeah.
the obstacle to do that could be a sort of way to measure that.
Yeah.
Thanks.
Okay.
Okay, wonderful. Let's thank Jim.